Gesture control robots basically follow and react to human movements. So a lot of human-machine interaction is involved. So let's see the components used to build the gesture control robot. And these are the components here. So this is the robotic chassis that we are going to use to build a gesture control robot. This is the main frame of the robot. And to get the movement, we have two motors and two wheels. And this is the front wheel of the robot, that is nothing but a caster wheel. And to assemble all these things, we have some basic assemblies like screws, couplers and T-joints. Here we have an electronics part of the whole robotic kit. These are the breadboards, jumper wires, and the main controller part is here. This is a Arduino Uno, Arduino Nano, then the accelerometer and gyro sensor, which is termed as MPU 6050, and this is a H-bridge IC. And these are the two Bluetooth modules which will help us to connect the remote part and the car part of the robot. So before moving to the assembly of the robot, there are two other things we need to know about. First one is Bluetooth communication. Bluetooth is a wireless short-range communications technology standard found in millions of products we use every day, including headsets, smartphones, laptops and portable speakers, and many other devices also use Bluetooth. It is mainly designed for communicating over short distance, less than about 10 meters or 30 feet. Here we are using for this project a HC05 Bluetooth module. So let us see what is that HC05 Bluetooth module is. HC05 Bluetooth module is an easy to use Bluetooth SSP module designed for transparent wireless series communication setup. Its communication is via serial communication, which makes an easy way to interface and control the PC, or it can be any other module. So HC05 Bluetooth module provides switching mode between master and slave, which means it is able to neither receiving nor transmitting data. So here we are using both of them to receive and transmit the data. So now let us see the working of MPU 6050. MPU 6050 is a gyro and accelerometer sensor. So IMU sensors usually consist of two or more parts. Listing them by priority, they are accelerometer, gyroscope, magnetometer, altimeter, etc. The MPU 6050 is a 6-axis control sensor, which means that it gives 6 values as an output. Their values from accelerometer and 3 values from gyroscope. The MPU 6050 sensor is based on MEMS technology. What is that MEMS? Micro electromechanical system technology. Both the accelerometer and the gyroscopes are embedded inside a single chip. So this chip uses I2C protocol for communication. So now let us see these two sensors, how it works. So accelerometer, how it works. An accelerometer works on the principle of piezoelectric effect. Here imagine a cuboidal box having a small ball inside it, as shown in the picture. The walls of this box are made up of piezoelectric crystals. Whenever you tilt the box, the ball is forced to move in that direction of inclination due to gravity. So the wall, which is, when the ball collides the wall, that creates a tiny piezoelectric currents. So there in total 3 pairs of opposite walls in a cuboidal box will give 3 different axes, that is X, Y and Z. So depending on the current produced from the piezoelectric wall, we can determine the direction of inclination and its magnitude. So this is how the accelerometer works. So now let us see how a gyroscope works. Gyroscope work on the principle of Coriolis acceleration. Imagine that there is a fork-like structure that is in constant back and forth movement. It is in the held place when when you are using a piezoelectric crystal. Whenever you are trying to tilt this arrangement, the crystals experience a force in the direction of the inclination. This caused a result in the inertia of the movement of the fork. The crystals thus produce a current. When it is sensing the current, the piezoelectric effect is generated, and this current is amplified. The values are then refined by the host of the microcontroller. So here the microcontroller that we are using is our Arduino Nano.